Good morning, everybody. Thank you for joining us. Hope you're in the right session. We're here to talk a little bit about platform events and give you a little bit of taste of how we can use platform event to solve some cool problems or annoying problems. This is Dreamforce, and thank you for coming. I hope you've been having a lot of fun. There's still 2 days ahead of you, so keep your energies up, eat, drink, and sleep. Before we start, I'm sure you've never seen this slide before. All that this means is that if we talk about something that is forward-looking, i.e. does not exist yet as a feature on the platform, don't make any purchasing decision. Don't buy Salesforce because of something that might come. And with that, quick introduction.
So hi, everyone. My name is Roy Gilad. I'm the founder of Arnav. We provide a solution to companies to manage their subscription on the Salesforce platform.
My name is Ohad. I'm the founder and CEO of Praxis, and we are a Salesforce consultancy. We do Salesforce implementations, development, integration, everything Salesforce, really.
So I started my way working with Salesforce back at 2009, and I've been blazing trails since then. During that time, I've accumulated 6 certifications. I initiated the user group in Israel, and I'm still leading it since 2010. And about 2016, I was recognized as a Salesforce MVP. Just a few words about the MVP program. The MVP program is a program that recognizes people with knowledge about the Salesforce platform and provide value to the community. And with me, a fellow MVP.
So I've been working with Salesforce since 2010. 8 certifications. I am an accidental admin originally, taught myself development. In 2014, started co-leading the New York City developer user group. Recently moved to Richmond, Virginia, where I now co-lead the developer user group there with my co-leader in the audience. Like Roy, I'm a Salesforce MVP since 2017.
And even though Salesforce is my life, I have other life besides it. I have my wife, I have 3 kids, 2 cats, and 1 dog that you can see on the screen. Her name is Noga, and she's cute as.
And in Richmond, me and my wife, we manage a portfolio of only 1 child and a cat. So still have something to do to catch up with Roy. And let's get in.
So as you probably noticed, our session will have some relations to governance limits. So let's briefly understand what governance limits are. So we live in a world. And the world that we live in, called Earth, in case you haven't noticed, and in it, we share resources. We share resources because we live in a shared environment. All of us are here. And as part of that, governments are actually establishing rules to help us facilitate that. In our work world, we live in a world called Salesforce. And to actually uphold, and Salesforce is a multi-tenant environment, meaning that if we consume a lot of resources, user experience, not to our company alone, but to all of you Salesforce customers, are actually being harmed. And Salesforce created, same as governments, the governance limits to help us understand and maintain the user experience within the platform. So let's have a couple of examples of governance limits.
So we all know and love the CPU timeout limit. Because the CPU is, again, a shared resource on a multi-tenant server, Salesforce makes sure that we don't use too much of the CPU. If we consume too much CPU time, that means other users on the platform cannot. And so one of the governance limits says a transaction can only last so many seconds before it reaches a timeout.
Another example of a CPU limit would be
governance limit?
Yeah, sorry. Another example of the governance limits would be the number of SOQL the number of SOQL queries that you can do within a transaction. The reason for that is that accessing the database is a very costly action. So Salesforce tells us, bulkify your access to the database, do as little possible access to the database, and bulkify it.
Another example is what we call the mixed DML limit. And so Salesforce, due to its architecture, has some limits on what type of data you can update within a single transaction. So as an example, you cannot update an account, which is a data, together in the same context, in the same transaction as updating a user, which is kind of a data and metadata combination.
So very similar to what we've talked about with governments. Recycling helps the environment, and upholding governor limits helps us maintain the experience of our users. However, even when we maintain those limits and we do everything according to the book, we do best practices, we bulkify everything, we narrow our transaction to use as little processing power as needed, sometimes, even when you do everything according to the book, you still hit a limit. And then you get really frustrated because why? I've done everything according to the book and still I hit a limit. So, Ohad, what were our options until now to actually solve this issue?
So until today, when you hit a governor limit, that really tells you one thing: go async, right? You have to take some of the processing you were trying to do and move it to process in the background. And so Salesforce gave us a few different methods to do that. One is our queuable methods, our future methods, which I hope nobody here uses futures anymore. We have our batches, and yeah, this is a batch of cookies. You have to work with me. And finally, we have our scheduled Apex, as well as time-based workflows and process builders activities. So hopefully everybody here understands the difference between synchronous and asynchronous. Just a quick recap. If we use an example of a user clicking the save button on an account record, for example, everything that happens between the time they clicked save and the page reloads is what we call our synchronous context, execution context. And that includes triggers, process builders, validation rules, assignment rules, and everything else that we know from the beautiful order of execution document that everybody here knows by heart, I'm sure. When we talk about asynchronous processing, if we use the same example, the user clicks save, and maybe we have a trigger that enqueues a queuable job. That queuable job really opens a separate thread of processing altogether. When our job goes into the queue, it will actually sit there in a holding state, and Salesforce will manage the availability of resources on the platform before it will actually start executing that code. Typically, that takes several seconds, but in some cases, it can take longer and even minutes in some scenarios. And from a user's perspective, that creates a gap in the user experience, right? User clicks save, he expects everything related to that save operation to be done, but now they have to potentially wait, maybe get a notification when it's done, or maybe just know that some things will happen after the fact.
But what if we had a different way? Because if I'm taking what Ohad just said, Ohad said we share resources with everyone. Everything goes into the same queue, meaning if some other company is pushing a lot of asynchronous processes into a queue, then my process will take longer than expected time. So with platform events, we're actually providing a different way. Not we, but Salesforce. Salesforce provides us a different way. What happens here is that we have a dedicated queue. We have something that actually knows specifically the limitations that we need, not exactly knows the limitation, but he's dedicated to the specific job that we want to have done. And so we can subscribe to an event that's listening. We can subscribe to an event and capture it. And this queue, we're the one that's managing it. We're the one that's actually saying what goes into that queue, where should we start, where should we move. And that's how we can actually solve this user experience. Because if we control it, then we know, or we can expect our completion of processing to finalize before the page reloads. And that's, of course, the solution to our frustration that we just saw before.
So a little bit about platform events. You may or may not be familiar with what they are. Platform events are essentially like a pipe that we can push events, publish events into. And in some ways, they're kind of like S-objects. You create them in the setup menu. You define what fields you want to have within them. But in some ways, they are different. The first thing is we all know that custom objects always have the __C suffix. With platform events, we have __E suffix. With S-objects, we can do DMLs, which really means insert a new record, update, delete, upsert, or undelete even records. And with platform events, we only have the ability to publish, which is kind of the equivalent of inserting an event into the pipe. With SObject, we can query the records using SOQL. With platform events, we can't actually go and query specific events. We have to use the streaming API or subscribers that listen to the events. With SObject, we have triggers on this object, process builders, and so on. In platform events, we also use sort of a trigger, but we call them subscribers. Subscribers can actually be triggers, process builders, or even external subscribers outside of our Salesforce environment. And finally, with an SObject, if we have two users that are in the same time clicking save or save on a new account, you could actually have two separate instances of the trigger running in parallel, one on that context of this user and one for that user. With platform events, regardless of who publishes the event, where they're coming from, the event's always going to this single pipe, one queue, and they are always processed in the order that they have been published. And that means there's essentially a guaranteed order of execution. Another thing, as I mentioned, it's kind of like SObject where we can create custom fields, but with platform events, there is a much smaller set of type of fields, no pick list, no lookups, and so on. So that's another consideration with platform events.
When creating a platform event, we understood the characteristics of it. We understood that we know which are the attributes that we want to do, and we can define them. There's another thing that we can define. We can define the publishing behavior. We can either publish immediately or publish after commit. And let's understand the difference between the two of them by looking at some code. So as you can see here, this is a very simple code. I'm creating an account on row 3, and I'm doing an insert on line 4. On line 5, I'm creating a platform event, and I'm publishing it on line 6. On the lower part of the screen, I have my trigger on the platform event, which is the subscriber. And I'm doing a select on the account in line 2. Now, if I'm choosing after commit in the behavior of the platform event, then in line 2, I would get the account that I just entered into the system, that I just committed to the system. However, if I'm defining the platform event to work immediately, then there is no guarantee that when I do the select below, I will actually get the account that I just created. And the reason is dependent on the amount of processing that needs to be done when committing to the database. So it's not waiting for the commit and then starting the process, but working immediately.
Also, if during that insert, there may be exceptions that happen. If there are exceptions that are thrown in the code on the top section of the screen, you could actually have a scenario where the record hasn't even been inserted, maybe due to validation rules or other reasons. And you still have published the event. When you choose the after commit, if there was an exception, the event will not even be published. A few other considerations before we start looking at some examples. The first one is, even though we think about platform events as kind of an asynchronous process, right? We, in fact, create a separate thread for processing the platform event for the listener. Platform events actually get the same governor limits as synchronous operations. So we all know, or hopefully we all know, that when we talk about asynchronous processing using queuable, batches, or scheduled jobs, we actually have some governor limits that are increased, like the CPU time, the number of SOQL or DML transactions that we're allowed to do. But with platform event triggers, we actually have to abide by the synchronous limits, the lower limits.
Having that said, we also have something different. We have the number of records within the transaction. Within a regular trigger, we have 200 records within the transaction. The subscriber, the trigger on the event, we have a limit of 2,000 records within a transaction.
And so when you think about it, if you have to process a much larger number of events within a single context, but you also have lower governor limits to do that, depending on what you want to do when you process the transaction, when you process the event, you may find yourself saying, how am I supposed to do so much processing in relatively reduced governor limits? And depending on what you're trying to do, that may be a problem. So Salesforce recognized that and said, we're going to give you a way to dynamically break the context. So let's say we have a scenario where we really have 2,000 events that were just published, and our trigger executes with 2,000 records in events in the trigger.new collection, we are able to dynamically, using, for example, the limits class, determine that we're getting close to reaching one of our limits, CPU or SOQL or DML limits, and then say, okay, I'm reaching close enough that I don't want to try another one. Let me tell the system to stop processing the current context and start processing from a certain record, the next one I need to process. So this gives us a really great way to control the size of our execution context, and we can do this much more dynamically than we can with standard triggers.
So after we went through what are governor limits, and we gave you a brief description about what are platform events and their characteristics, let's get our hands dirty. And we have John. John is an administrator in organization, and he got a request. They want to track role changes. If somebody is being promoted, there is a record within the system that actually manages that. So let's see the object. So he created a regular object. He called it a role change request. And here we have Mr. Skywalker, and he's a young.
This is small, by the way. Should I zoom in? You good? Okay.
Right. Okay. So we've got Luke Skywalker. Luke Skywalker is actually at the moment a youngling, and he's being promoted to being a Padawan, which is a great promotion. And so what John has done, he created a process builder. The process builder checks whenever the approval is, whenever the record is being approved, then update the user. Makes sense. So let's see. This is a very simple process builder. He goes in, and he changes to approve, click save, and he's getting an exception. Which exception is he getting? He's getting the mixed DML. And why is he getting that? Because he's trying to update record, which is the role change record, and he's trying to update the metadata, the user itself. So John thinks how he can solve it. And he thinks about it, and he breaks it down into two. So he's created a platform event. The platform event is actually listening to the changes in the role update. And what he sends the new role that he needs to be transitioned to and the user ID. And now he creates a new process builder. The process builder, again, with the same condition, when the record is getting approved, but this time, instead of trying to change the user, he's publishing a platform event. And to actually, from there, we take it to a different transaction. We have a platform event. We have a process builder on the platform event that listens, captures the user ID, and always changes the role based on the value that was propagated from the platform event. And so we took down a process. We split it into two transactions. And now let's activate the process builders and go back to Mr. Skywalker and save and power. And let's go to the user role. He was a youngling. Let's refresh the page. Managed. Sorry, page loading times. Padawan. And he's a Padawan, which is a great progress. He's onwards and upwards.
So we saw how we can use the process builders to publish events and even listen to these events using a process builder. But let's look at another use case. Still looking at mixed DML exception, but this time they tried to do something new. They wanted not only to change the role of a user, but rather when a user role is changed, they wanted the user to be removed from a public group that's associated with that role and assign the user to the public group that is associated with the new role. That cannot be done with the process builder, so they contacted Jennifer, who's a developer, and asked her, how can we do this? So Jennifer thought about it again. She saw that John already used platform event to publish when a role is changed and said, oh, I can probably use the same kind of architecture. So she went ahead and until this happened, the change in the public group had to be done manually. So after a promotion, somebody would have to go to the old public group, remove Luke from it, and then go to the new one and add them to it. And so we just removed him from the youngling. We're adding him to the Padawan public group. And so what Jennifer has done she has created a new platform event specifically for the purpose of group membership. And so here we have 3 fields on this platform event. The first one is the user ID. Who is the user we're trying to change group membership for? We have the group name. What group are we trying to add or remove him from? And the type, which will be telling us, are we trying to remove him from that group, or are we trying to add him to a group? So we can use the same platform event to do both the add and remove from a group. Then she went ahead and she turned off the process builder that John created, or rather she cloned it because she wanted to add another publishing event to it. So she deactivated this one, or cloned it, and we look at the next process builder. And what she has done is exactly the same thing. The first published platform event is the same one for the role ID, but now she has also added 2 additional platform event publish event actions. The first one we can see has the group remove, and it has the role name, the group name based on the prior value of the user's role before the change. And the third one is the one that will add him to the next group. And so now, because we cannot do group changes in Process Builder, she actually had to write some code to do that. So let's look at what this code looks like. We're not going to read this entire thing line by line, but if you can scroll all the way up for a second. So in essence, what this code does, it gets all the events that were published. And in our first loop in line 9, we're basically just creating a collection of unique group names across all these events. Next, in the group, in the for loop in line 15, we're building a map that allows us to then get the group from and the group membership based on the user. Not so important. What we want to concentrate on is the loop in below line 32. Below. And so in line 38, this is now we've collected all the group memberships that exist, and we've identified all the data we need, and now we're actually going through the events again and determining what we need to do. So in line 42, we see an if statement that says if the platform event type field is group add, that means we need to add the user to the group membership. The other conditions actually also check that the user is not already a member of that group. We don't want to try to add a user to a group he is already a member. We'll get a duplicate record exception. And if the user is not part of that group, we'll then just create in line 45 a group membership and add that to a list of new members that we need to insert. The if statement in line 50 says if this is a group remove event, and we also want to make sure that the user is already a member of that group, because if we get an event to remove but the user is not a member, then there's nothing we need to do. And then we just add the group membership that we queried above to a list of records that we want to delete. And then finally, in line 55 and 59, we check if there are any records to actually commit, being insert new group memberships or delete existing group memberships, and we do the DML transactions then. And so if we go back, Luke has now received his second promotion in a single day. We all know that Luke is a very, very sharp guy. And so we now see his current role right under his name is Padawan, and we now update him to a Jedi Knight. So let's update the status from not submitted to approved and save it. We now know that the role should have changed, but also that the user should have been added to the Jedi Knight group. Wow, it actually worked. And then we can also see that he was removed from the Padawan group through the group remove platform event. And so, again, using platform event to solve a mixed DML limit that we would otherwise hit, we can now use this platform event to do these things. And what you noticed, or you may not have noticed, is how quickly this all happened. When we clicked save, because this platform event is not really bombarded with a lot of events that it has to process, we can reliably consider the fact that as soon as we publish, or very soon after that, the listener will start executing. And that is a significant difference from using futures or queuables to accomplish the same task. And with that, back to you, Roy.
Thank you.
Wow.
Yeah, sorry, got mixed up there. So we saw, in our first use case, we saw a declarative way about using platform events using process builders. In our second use case, we saw a declarative plus code for listening to platform events. In our third one, we're going to do some architecture and going to look at it. So we've got Maggie. Maggie is an architect within the same company, actually. And they were tasked by managing large volumes of transactions, meaning whenever somebody is being promoted, we need to take the opportunities that they are managing, redistribute it according to the users that uphold the previous role, and then recalculate the commission, and then also to send it to the ERP system, to an external system. So the challenge here that Maggie actually thought about is a bit complicated. So she drew it down. She drew it down, and then she looked at it. She said, OK, I've got a role change. That invokes a process. And then I need to do, in parallel, because that was the business requirement, I need to send data to the ERP, and I need to do the recalculation of the commissions. Since we know that Maggie is working in a large volume environment, these things needs to usually go by async. It needs to be asynchronous. So Maggie sat down, and she opened up VS Code, and she started writing code. She started writing code, and she wrote the first batch to do the changes of roles. And then she wrote two different batches, one to send to the ERP, and one to do the recalculation of the commission. So we've got one that calls two of them. And now let's go and try and run what Maggie has written to launch batch. And as you can see here on the second row from the top, we've got an exception. We're trying to enqueue too many asynchronous processes. And the reason for that is because when you do in the final method, and you can only enqueue one other.
You can only chain one job at the
chain.
end of an async job.
Yeah, you can only chain one async job. So she went back to the drawing board, and she opened up again the VS Code, and she said, OK, you know what? I'm going to use platform events. I'm going to have the platform event fire from my code, and the platform event is going to call a class, and it's dynamically configured. So she's transitioning the class name into the platform event, and also the batch size. And then she goes back to the VS Code.
I'll do it here if that's OK.
OK, I'm fine with you. She changes the code from enqueuing them. What she's actually doing, she's creating a platform event list, and then she's publishing two platform events in one transaction, each of them with the class that she wants to invoke. And now let's try. Now she added also a listener on the async process class. It checks if it's a queuable or a batchable, and according to that, it enqueues them into the general queue. And now, if we'll go back and see what Maggie has done, and success, 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 a lot of records of success, which is great, because we actually succeeded in upholding what we wanted to do. And so using this platform event architecture, Maggie actually managed to solve an issue that until now wasn't possible using you could hack around your way around it, but that would be like hacking. And we don't like hacking. We like to work according to the book. And so actually, Maggie managed to solve this issue.
Sorry.
All good.
Just made a mess of this.
You can see the platform event being fired. You can see two queuable handlers being fired, and also the batch. OK. And let's go back.
So we gave you a little bit of a taste of what you can do with platform events, right? There's obviously a lot more we can do, and we'll touch on a couple of additional examples briefly in a moment. But the beautiful thing here is that we can use platform events to really do things that traditionally we couldn't really do, right? Again, we have a limit. We cannot chain more than one async job at the end of another async job. And there are many, many use cases where we actually have to do this. So using platform event is a really effective and quick way to do this really, really well. A few other examples of things that we've done with platform events. So multi-threaded processing. This is almost kind of like the holy grail of Salesforce development, right? Because we know that in Salesforce, we really only get one thread. Whenever we want to do something in another thread, this requires async jobs, right? Batches or queuables. But batches, we're only allowed to run 5 batches in parallel in any org. So that's a really strict limit. And if you're doing a lot of things in your org that would typically require a batch, you're kind of starting to have to think, how do I manage it? And in large organizations, you would want to make sure that teams don't abuse the batch queue. Even with queuable jobs, you only have up to 100 jobs you can enqueue. And everybody goes into that queue. Every queuable job that you enqueue will go into that queue. And so again, you may reach this scenario where if a lot of people inside your organization are using queuables, you may have a scenario where you enqueue something and it may take a long time before it reaches that job in the queue. So by creating purpose-specific platform events, you're actually creating threads that are designed to handle a specific task. And with a little bit more ingenuity, you can even use many platform events to do the same task and use some kind of a round-robin mechanism to distribute the work to different platform events. And you can create an almost real multi-threaded processing. Another thing, we mentioned very briefly that we can dynamically control the size of our context, right? So again, just the ability to query the limit class and say, hey, I'm close to a CPU limit or I'm close to a SOQL limit, and say, okay, then I'll just need to break my context and start processing in the next one, is something that we couldn't do until now. Web service callouts. We cannot do web service callouts from triggers, right? So we know that whenever we have an update in a record that we want to do some kind of a callout, maybe to update or get information from an external system, we could not do that from the trigger. We'd have to, again, enqueue a job. Now, there is a caveat here, this little asterisk there. Because platform events today use the trigger framework for Apex listeners to the platform event, we still cannot do, from the trigger on a platform event, we cannot do a web callout. And this is the only future forward statement. Salesforce is going to actually make changes to allow that in the future. But the workaround for that is if you actually, instead of using the trigger framework, you have a process builder that listens to the event and call an invocable Apex method, you actually can do from a platform event listener a web service callout. So that is something that can be very transformational for somebody who needs to do callouts much faster than having to rely on queuables. And finally, just like we can create Apex services that are reusable, we can create platform events that no matter where event is published from, as long as we pass in the right information, it will do the same thing. So now you can have code, process builders, or external system publish events that will always do the same task. So it's, again, just this another approach to creating modularity and reusability in your functions in your environment.
So just a quick recap. We created a trail mix for you to actually get your hands on and get the understanding of the basics of to get the understanding of the platform events. The second thing, we will upload our code to our GitHub repository.
We'll publish it on the chatter group for this session. So that will include all the metadata, the platform events, the objects, and the code samples, as well as the process builders we've created.
The last thing, but not least, which I want to highlight, the documentation around platform events is really good. You can actually get a really good understanding about the basics of platform events. Again, this talk was a bit more than what is written down within the documentation, because the documentation doesn't tell you about how to work around limits. And so that's actually how to work with both of them. And just to summarize, we talked about why we have governance limits. We talked about why we have platform events. and how the two of them can work combinedly. It's an interesting thing because using that, we can actually have user experience better. And as we talked, it's helping our users, which is helping our ecosystem, which is Salesforce. And also, hopefully, we could help the environment in some way because it makes us think about how we can help the environment. And that relates to Mark Benioff's talk on the keynote. So that's it for us. And
we'd love to hear from you. So if you have any questions, first of all, there's a microphone here. You're invited to talk right now. Ask questions. And again, we'll be outside after the session, happy to answer any questions. All of our contact information, except for phone numbers, is on the screen. So feel free to connect with us online. And we're always happy to field questions and help you guys. Any questions? OK.
no, wait.
So the question has to do with, there's governor limits also against these, the new events as well, right?
Mm-hmm.
So just like with @future, you have daily limits for the @futures, you have daily limits against these as well, right, against the events.
Yep.
So it's not a complete panacea. You have other limits you have to consider.
Yeah, that's absolutely correct. There are limits on the platform events, and as I mentioned, they are the synchronous limits. But just by the ability to break into separate threads, you're able to just do more work. Again, it's not very different in that context of using. It's not very different from using queuables, right, or batches to do to get around your limits. But it's just another mechanism to do that. So it's another tool in your developer utility belt. And the extra benefit is that you can process things a lot faster by using platform event than waiting for a queuable.
And I'm going to add also to what Ohad just said, that at the moment, there aren't many or almost none implementation using platform events. So this is kind of a fast lane that you can bypass traffic really easily.
Any other questions? OK, well, thank you very much for joining our session. We hope this was valuable.
Happy Dreamforce.